graphing. Graphing is really nice when you're able to like get y by itself and when they cross at small numbers. Substitution works, but if you don't have a variable that's like just x or just y, sometimes you can get some weird fractions. So today we're going to go through elimination. Elimination is the preferred way to solve systems. It's also the way that'll give you the least restrictions. When you have elimination, your first thing that you always want to make sure is that everything's lined up. So like x is on top of x's, y is on top of y's, and then they equal your numbers. After that, you really just have to make sure you have one variable with the same number but opposite signs. Because when you eliminate something, it means we're looking to make something cancel. So in this case, do we have a variable like x's or y's that have the same number but one positive, one negative? No. So to change that, we have to use multiplication. So looking at your variables, we have a 1 and a 5 and we have a 2 and a 6. Is there something that we can easily change them both into? If you look at the y's, what can 2 and 6 both be made into? A 6, right? So if we have a positive 6 down here, what would we want this to be? Negative 6. So we'd use multiplication to change it. So what is going to make a 2 into a negative 6? Negative 3. As long as you multiply everything in that equation by negative 3, you're not changing the value of it. So negative 3 times x, 2y times negative 3, negative 9 times negative 3. Just 27. Do we have to change the second equation at all? No, so just copy it down right underneath it. And once you have it set up where you have one variable with the same number, opposite signs, we have a negative 6y and a positive 6y, we're just going to add the equations together. So draw a line underneath them, because what is negative 3x plus 5x? Just 2x. What's negative 6y plus 6y? 0. So that's why it's called elimination, because we just eliminated our y's. And it's going to equal 27 plus negative 13, 14. Once you do that elimination, what's the only thing we have left to do to get x by itself? Divide by 2, so x is 7. Once we have our x, how do we find the y that goes with it? Plug it in. Go back to the one of the original. So should we use our first one or our second one? I would use the first one just because it's smaller numbers. So 7 plus 2y equals negative 9. What do you move next? Move the 7, so 2y equals negative 16. Y, not 8, but negative 8. Which means do these two lines cross? What point do they cross at? Since we got one answer, what would its label be? Independent, it got one answer. How do you know if you're right or not? You plug it in. So you can take it in your second one, 5 times 7 plus 6 times negative 8. What is 5 times 7? 36 times 8? Yeah, good point. 5 times 7 is 35. 6 times 8? Is 35 minus 48 negative 13? Yeah, so you'll always know if you're right or not. So the main thing is you just have to multiply at the beginning to get one variable with the same number, but one positive, one negative. Next one. As is, do we have one variable with the same number, one positive, one negative? No. We have a variable that has the same number. Which one, x or y? X. So they're both a 1, so that's really good. So the only thing we need to switch is we need one of them to be positive, one of them to be negative. So if you just need to switch the sign, what do you multiply by? Negative 1. It doesn't matter which one you multiply by negative 1. You just have to pick one of them. Because if they already have the same number, we just need to switch the signs. So my first one is good. My second one, negative x. What's negative y times negative 1? Positive y, and then 4 times negative 1? Negative 4. Once you have that set up, draw a line underneath it because that's you showing that you're ready to add the equations together. What's going to happen to our x's? They're canceling, they're gone, they're eliminated. How many y's do we end up with? -3, so -4 plus 1. And then 31 minus 4, 27. As soon as you do that elimination, you should be able to just divide to get one of your variables. In this case, what's y going to equal? Once you have your y, how do you get your other variable? Plug it in. Doesn't matter which one you plug into. No, the bottom one looks a little bit easier, so x minus y equals 4. So if you minus a negative, what will it turn into? Positive. So what will x equal? So what point do these guys cross at? One answer, so it's independent. You guys remember doing this in Algebra 1? So this is our go-to. Unless I explicitly tell you that you have to graph or use substitution, this is what we're going to be using. This one. Do we have a one variable with the same number but opposite signs? No. So just pick a variable to look at. Do we want to get rid of our x's or our y's? Your y's, perfect. So between a 3 and a 6, what can they both be turned into? A 6. This is already a -6y, so what do we want this to be? Positive. So what do we take -3 times to make it a +6?
2.
-2. So if you need to change the sign, you just throw the negative in front. What's 4x times -2? -3y times -2. And then 13 times -2. Do we need to multiply the second equation at all? No. So you just copy it down. Add them up. So what happens to our x's? They cancel. The y's. So what's left on our left-hand side? Nothing. And then -26 plus 26? 0. Same as yesterday. If your variables go away, you just have to ask yourself how often. So always, good. 0 always equals 0. So what type of system gives us always answers? Dependent. So our actual solution is infinitely many, IMS. 0 equals 0 means it's always going to give us an answer, which means we have infinitely many of them, so it is a dependent system. These lines, are they parallel or are they right on top of each other? Right on top of each other. So those rules are the same, regardless if you use substitution or elimination. If this had ended up being 0 equals 9, then what would our answer have been? Inconsistent, no solution. So those rules are the same, which makes it kind of nice. Now the story problems. We are doing story problems in the notes here. We didn't do any yesterday. Yesterday's homework is not going to be turned in until tomorrow. So yesterday's and today's homework are going to go together. So if you're stuck on the story problems, hopefully this will help kind of clear it up. Because once you have the equations written, you just either use substitution or elimination. The first one, you guys read it on your own. And this is where you either write small or you might have to write off to the side of your box thing if you don't have enough room in there. So when you have a story problem, your first step is always figure out your variables. Your variables are what you would draw a picture of or what question you're being asked. So reading this, if you have to draw a picture that would show this, what would you draw a picture of? What picture would you draw? What would you draw a picture of? Hamburgers and fries. So in some way, our variables are hamburgers and fries. And it's not the amount of hamburgers and the amount of fries. They tell us that. What is it about the hamburgers and the fries? The calories in them, because that's what we got to figure. That's a terrible C. So it's the calories in a hamburger and the calories in the fries. In the end, that's the question they're asking is how many calories are in both. So the question at the end is going to tell you what your variables are. Now, Ethan, what's our first equation going to be? Perfect. So they give us the first scenario. They bought 4 burgers, 3 fries, and they equal this many calories. So that's the first scenario. So then what would the second equation be?
6x plus 2y plus 2 plus 5 60.
Perfect. Because they give you 2 different orders of what they ordered and then how many calories. So each order is its own equation. Now we just have to do our elimination. So do we have a variable that is the same number opposite sign? No.
Top one by -3 and then the bottom one by 2.
Good. Okay. So when Ethan says that, like, what can a 4 and a 6 both be made into?
12.
A 12. So 4 times 3 gives us 12. 6 times what gives us 12? 2. And since these are both positive, we need one of them to be negative. So just put a negative in front of one of them. It doesn't matter which one you pick. You could have done the same thing with the y's. It doesn't matter. Just pick a variable, make them into the same number. 4 times 3 will give us a 12x plus 9y equals
-68, 70.
You keep going with yours, Ethan. I put my negative in the other spot. Make sure you multiply all 3 parts by that number. So then our second one, there's our negative 12x, our negative 4y. Perfect. Once you do that multiplication, the line underneath, that's where I look for in your work to show, like, this is where the actual elimination is happening. Which one is going to be eliminated, the x's or the y's? The x's. How many y's are we going to have left? And then just be careful with the calculator. $1,750. Last step, how do you get y by itself? Perfect. So regardless of how you solve this, y is 350, which means how many calories are in the fries? 350. Once you have one of your variables, how do you get the other one? Plug it in. Technically, you could plug it into any of these 4. I would not plug into these ones because they're bigger numbers. So go back to the originals when you plug in and just pick one. Doesn't matter which one. How many calories are in a hamburger? 310. When you're in a story problem, do we write this answer as an ordered pick? No. So just at the very end, make sure you put like 310 calories in a burger, 350 calories in the fries. Questions on that story problem? All right, the next one. The Smith family went to the theater to see a movie. Adult movie tickets cost, I forgot the word cost, $12, and child tickets cost $9. If they spent $72 total and purchased 7 tickets, how many of each were purchased? So what would our 2 variables be in this equation? Adult tickets and child tickets. Okay, you guys try this one. score for this one. You're good. If not, make sure you ask for help. Last story problem. This was like one of the story problems on yesterday's assignment. The only difference was that one was dollar bills and $5 bills. So Aiden has a collection of 63 nickels and quarters in his piggy bank. If the total value of the coins is $10.75, how many nickels and quarters does he have? So if you were to draw a picture of this, what would you draw a picture of? Nickels and quarters. So we know that X's are nickels, Y's are quarters.
Hard to write in the Q.
Oh yeah. So is it the amount of nickels and quarters or the like cost of nickels and quarters? It's the amount, because we know what these costs are. Your variables can't be numbers. So it's just how many nickels he has, how many quarters he has. So he has a total of how many coins? 63. So how would he write if he had a total amount of 63 coins? What would that equation be? X plus Y is 63. So that 63 is just a counter. So he counted how many quarters he has. He has 63 of them. Now the cost of those, or the value of them, this is where you have to know like what things are worth. So total, how much money does he have in his piggy bank? $10.75. To get that, his nickels, each nickel is worth how much? 5 cents. So since this is written as a decimal, that's how much a nickel is worth, 5 cents. How much is a quarter worth? 25 cents. That's our second equation. Yeah.
Couldn't you technically write that equation 5x plus 25y equals 1,075?
Yeah, you can multiply the decimals if you want. I would suggest leaving it as decimals because if you don't remember that trick, you're going to set 5 plus 25 equal to 1075. But the decimals are fine. Use a calculator. Do we have a variable that's the same number but opposite sign? No. This one, it's not as tricky as it seems because these are both ones in front. Is it easy or hard to change a 1 into anything? Mm-hmm. It's really easy. So if we want to get rid of our x's, what would I need to multiply that first equation by? Negative 0.05. So if you know that you just need these to match up and one of them's a 1, you just multiply it by the other one. And then that'll give you negative 315. Second equation doesn't need to change. So that multiplication, that part gets kind of messy, but it's not that bad. So if you have 25 cents and you're taking away 5 cents, how much are you left with? For the y's, what's our y's going to be? 20 cents. And then negative 315 plus 1075. Calculators. 760. How do you get y by itself? How many quarters does he have? 38. Once you know the quarters, how do you find the nickels? Plug it in. Should we plug into the first one or the second one? I would do the x plus y one. So how many nickels? 25. So he has 25 nickels, 38 quarters. So that story problem on yesterday's assignment, same idea, except for instead of 5 cents and 25 cents, it'd be $1 and $5, but same concept. The homework today is also already shared in Classroom. You're just gonna put it on yesterday's homework. So your substitution and your elimination go together. Be careful, you are only doing the odds. So 21 through 41 odds only. which means how many problems do you have added on to today? Like 10 problems. So it's not that many. Tomorrow we have one more type of system to look at. Thursday review, Friday quiz.